Hi, I'm Tom from Orangebeard, and today I would like to talk to you about software testing and how history in software testing is repeating itself and we are seemingly unable to do something about it. Well, I think we are, and I would like to talk about how we can do that. So software testing is something like a loading bar. We're always waiting for testers to finish their work. And to find out why that happens, we need to dive into a little bit of software testing history. So I've been in testing since 2005, so a couple of years now. And I started out in what we now call old-fashioned waterfall projects. Big projects, taking a long time, and having a release to be tested was something that we all were looking out for because it didn't really happen that much. Release calendars looked somewhat like this. We had a year, and if we were lucky, we could do releases every 3 months or maybe every 6 months, or if we were really unlucky, it would be every year or so. So process, you all know it, was like starting with a designing the product we needed to make, finding out all the specifications, writing functional specs, then going for the technical specs, then starting up with development when everything was done and set in stone. And we started developing software. And developing the software was really taking up most of the time because that's the work we're doing. So we need to take most of the time developing software. And then when the software is finished, then at some point, say after 6 months of development, we had about a month of time to test our software. And after testing, we could release it and then get it to production, which is nice because that's the point where somebody really can use the software. So, sounds good. In practice, it was going to look a bit more like this because testers, they started testing, and those bloody testers, they found issues with your software. They found stuff that didn't work as expected. They found stuff that didn't work as designed, stuff that was built perfectly by design but didn't cooperate nicely with other things from the same design. And this month we had for testing was like 3 days of testing, sending it back to development to fix, then retest stuff, finding new stuff that didn't work again, and then we started fixing it, and then testing it, and then fixing it, and then testing it, and the deadline was coming closer, and everybody was eating takeout food for weeks now, and then we started to panic. Testing was taking too much time. It was on the critical path. Testers had a lot of work to do, testing all the flows in the application. We were mostly looking at user and end-to-end flows. So it was just not that quick. So how would we go about fixing that? Well, 2004-05, I think we started doing this. We found the holy grail, the solution to all of our problems, test automation. And test automation is great. I mean, test automation doesn't make mistakes. It can do the same thing over and over again. It doesn't get bored. It's quick. It can click through an application a lot faster than you can and I can. Right? So no problems there. Well, in fact, automation took a lot of time to automate. We had to build automation frameworks. Tools were not very mature back then. Took a lot of time. In practice, we had software testers who were mediocre developers at best, writing very complex test frameworks to see if the code in the software that was built by the professionals actually worked. Well, it didn't really work as expected. So automation was used to maybe automate the tester, but not really the testing work. So around 2010, we started doing agile things. And agile was the new solution to this problem because testing with all that automation in place was still on the critical path. The work of the tester by executing test cases was somewhat automated, which meant that we could run more test cases in the same time without getting in trouble. But still, when the application broke, it had to go back to development, it had to be fixed, and all those test cases had to be done again. And all those test cases had to be refactored because something changed in the code and the test case was not that robust, and then it was flaky, and then it didn't really help. So, Agile, good solution to most of these issues, you'd say. So, smaller iterations, more releases, more testing, more automation automatically, should have led to shorter testing times, being able to release more software. And that there was a movement there, but as soon as we got that stuff running, we went to a sprint demo date, the moment we would like to release at the end of the sprint. And then we found out that there were still 25 stories in test, because we were doing mostly small waterfall processes. We had some more stories in Jira because there were all new work items from the bugs we found. So the work wasn't really done, but we couldn't fix everything because we only had one day we had to release. And as a result, we started making extra planning sessions to plan all the work for all those bugs we found. And then the problem was repeating itself a bit more because, again, we had a release, we had testing on the critical path at the end where we would want to release, then it would stall the release. We could all blame the testers again because they didn't get their work done in time. So we needed to automate some more. So what do we need? We need pipelines. We need a pipeline that does everything automatically. That's a good idea because you can build stuff, then you can test stuff automatically. You can do the unit tests, you can deploy it to an environment, then we can automate the acceptance tests. And everything is automated. Fantastic. So slowly, we were moving from agile work into some sort of continuous delivery situation. So how does that work? We have code. We create a branch of the code, and then we commit some changes to it. The changes are automatically unit tested, and then if all the unit tests are green, we can deploy it to a testing environment, which is nice. Because in the testing environment, we can run some tests. We can run acceptance tests, we can run regression tests, we can run all kinds of tests that we want to do in our software to make sure that we can, in the end, safely deploy to production with all the risks mitigated. Well, that sounds nice. And what happened? We were able to very quickly get some software to production. So from once every 3 or 6 months per release, we went to releases every 2 or 3 weeks in the sprint. And now we had the opportunity to do continuous delivery and release multiple times every sprint, maybe even multiple times every day. So these pipelines, they started to stack and stack and stack, and the build ran in 20 seconds. The unit test, it takes about 4 or 5 seconds. Pretty nice. Deployment to test takes a little bit longer, maybe 2 minutes. And then the acceptance test, it takes 8.5 hours. Oops. Again, testing is on the critical path, and we have a lot of test cases that are taking up a lot of time, and we're always running them because we need to know that we are not taking any stupid risks when going to production. So where we would want to go to production multiple times a day, we have multiple pipelines, and in the end we have one testing environment or one acceptance environment where all the testing needs to be done. Again, we're waiting for those bloody testers to get their work done. Even if it's automated, it's still the tester's work that is taking up all of this time and stalling the release to production. And our customer is still waiting for those bloody testers. So we keep doing the same thing over and over again, but it just kind of scales a bit different. Instead of doing the same thing every 3 months, we now do the same thing 3 times a day, but we still do the same thing and we run into the same problems. So if we're doing the same problems, do we really expect to see a different result from it? I think we do, because otherwise we wouldn't keep on trying doing the same things. But what is the actual problem here? The actual problem here is that we're doing a lot of testing, and we have autonomous teams, and we want automation, and we have a lot of tools for that. And all those tools, they can be used in different ways. So we have the unit tests, usually not a very big problem. Then we get some integration or component tests. Well, infrastructure-wise, it gets interesting there, but most of the time it's not a very big problem to run them. Then we get to end-to-end testing, or acceptance testing, or testing on the UI, which is slow, relatively unstable, especially when compared to the other sorts of testing we do. And with all the teams who are able nowadays to make their own decisions in what tools they use. Teams are very much self-supporting, autonomous. We see in one organization that maybe 10 teams have 7 different sorts of test tools. And they're all developing systems that integrate together, that have to work together. This testing takes time. And then when the testing is done, there's issues to be analyzed. And then we have reports. Those reports from all those different test tools, they're all different. One test tool reports to the console, another one gives a nice HTML report. The third has an online reporting environment. Number 4 has XML that you need to decode for yourself to figure out what worked. So you need to learn how to analyze all those tests. You need to be able to do a root cause analysis from a failed test to the reason the test has failed. Well, having all those reports doesn't really help, and the tester usually, after a day of analyzing defects, looks a bit like this. He's not happy. He's using more time than he wants to use on reading through unreadable reports, finding out that defects are something they already encountered some time ago. And then after 6 hours of analyzing, it's like, oh, we've seen this before. This was the same issue. A backend service was not up in time, and that's why all of our tests have failed. And now we have to run them again because the service is up now because it was a startup or a wake-up problem. We also have the tendency to keep running all the tests all the time. No need to look at the context. We just run all of the tests. All those 6.5 hours of testing, we do it every time. Why do we do it every time? Because we have no idea what we could skip. 2005, we had a test manager. The test manager had this immense Excel sheet, and when he ran out of the 65,000 rows that were available in Excel, he would turn it into an Access database. And it had all the test cases, and it had all the requirements. And when, after 6 months of development, the changes came, then the test manager would look at his book of knowledge, and he would say, we need to run this test and this test and this test first, and then we have a pretty good idea. And it was some sort of dynamic smoke test idea where we could do the things that were the biggest risk, we could do it first. Nowadays, we have tens of thousands of tests. All of them are automated. We don't really know what correlates with what. We just run them all the time. And that's the point where we run into the problem with the pipelines, where testing takes too much time, where the pipeline is cluttered because a 6-hour test is running and the other team also wanted their change to production. But they have to wait because the environment is busy, so they can't do anything and everything stalls. We already have a lot of data to do the right thing. There is a lot of examples where test cases have the tendency to fail together. We all have, if you have a web application that has a login, you have an authentication test case, made it at the beginning of the project. Given I enter the right credentials and I press the login button, then I expect to be in a logged in situation. That's very nice. Now fast forward a couple of months or maybe even a year, and we have lots of functionality behind the login. And we have test cases, end-to-end test cases for all of them. Well, if the first test case with the login fails because the login isn't working anymore, then all of the other test cases will fail as well. There is absolutely no reason to run all those test cases because you already know they are going to fail in the first second. So unnecessary waiting. We also know what changes we made. We've seen situations where somebody changed a README file and 6 hours of testing commenced. And other teams were waiting for it. But there was no reason to run all those tests because we didn't change any functionality. It was just a commit for a typo in the README. We also know who changed something. We also know when something was changed. So we can use that to assess the risk of a change. Is it the new guy who just started yesterday doing a big change in the core of the software? You can argue if that's a good idea, but if that happens, maybe it's a different risk profile than an experienced developer that works on the same project for over a year doing a simple change. We also know unit test coverage because it's easy to measure. So if a specific part of the software has very good unit test coverage, maybe we can assess a different risk from stuff failing because of the changes that were made in it. We also know what mocks were affected. If we change stuff, we can see in a good component or integration test that integrations have changed or maybe have not changed. And if they haven't changed, then maybe the whole integration test can be a bit smaller. So we know a lot of things, but we're not using it. So how can we do that? Well, there's this AI hype, so let's jump on the bandwagon. And how can we use AI in testing in a good way instead of using it for stuff that humans are particularly very good at? We've seen a lot of tools leveraging AI image recognition to make sure that the tool knows what a shopping basket in a web shop looks like. Well, I'm pretty good as a human at determining where the shopping basket in the web shop is. What I'm not so good at as a human is making rational decisions, not letting my feelings about stuff get in the way. Also, as a human, I'm not very good at spotting patterns in very big loads of data. Humans are especially very bad at throwing stuff away. So maybe we can ask some algorithm to help us suggest what we could throw away, because everything we throw away, we don't have to maintain anymore. So that's what we are trying to accomplish with Orangebeard as a project. So what do? We're indexing all the logs of the tests that we run, so we can reuse them. The example from earlier where a tester was doing a couple of hours of analysis only to figure out that something went wrong that also went wrong a couple of weeks or a couple of months ago, but he forgot about it, or his coworker found it and is on vacation right now. So we can see what happened, and we can suggest a reason for a failure before the analysis has even started. We can use information about what tests add what value to make sure we can throw away stuff that we don't use anymore. Software testers are a bit of hoarders. If you've created a test and you've put some sweat in it to make it stable, to make it quick, to make it actually report something useful, it's hard to throw it away. But if that test is never actually finding anything and is superseded by a lot of other tests that implicitly test the same functionality, maybe it's good to just throw it away at some point. So what we shouldn't do is repeat everything all the time. What we can do is repurpose stuff. We have the requirement to do performance testing. We have the requirement to do security testing. This takes a lot of time because we need to create click paths. We need to figure out how the application is used, where the problems can be. But we can reuse tests that we already have for that. If we are talking about paths through the application, regression test sets usually are a very nice place to start. So what Orangebeard also tries to help with is to repurpose those tests to, say, build a context for a security test. Use the output of a regression test to feed a performance test run. So what we're trying to do is to break with traditions. We're always doing the same thing, and it's a lot of fun doing it, and I still like testing a lot. But sometimes the things we repeat and the things we keep on doing are actually not that smart. So let's test a bit smarter. So let's get back to 2018. we were still waiting for this regression test. And we just started it 30 minutes ago, so we have 6 hours to go. Well, what we would like to do is make that process a bit smarter. So what we're doing is creating an accelerator for your CI/CD process where we can be quicker, where we can test those things we really need to test instead of testing everything all the time and just steering on green and red dots. Making sure every test is green is nice, but if you don't know what that means, I can make 1,000 tests that turn green in 5 seconds, and I can really impress my test manager with that, but it doesn't really add anything. So what do? We subset based on the changes we have. If we know that a specific change or a change in that specific part of the code has previously triggered a test to fail, then it would make sense to at least run that test that has failed in the past. We can prioritize sets to make sure that the tests that have the biggest likelihood to fail, that we can test those first. Why is that? Because if something really important starts failing right away, then we don't even need to finish the test run, or at least not finish it on the critical path of testing. Make sure it gets sidetracked. Make sure it doesn't clutter the pipeline. It doesn't stall the other teams from releasing. So prioritizing, doing the right things first and not doing stuff that we don't need anymore. So the input we use, already told that a bit. What did we change? Did we change the README? Don't run any tests. Did we just change one test and nothing else? Well, maybe it's a good idea to just run that single test. We know who changed something. We know when they do it. We know what was already tested. So we combine this information into an algorithm that gives a suggestion on what do you want to test at what point, given your context, and making sure the process gets a bit smarter. The process would look a little bit like this. So you have a change. Something triggers a CI build or a test run to start. Some CI tool starts that pipeline or that run. And then instead of just blindly running the whole test, it would say, hey, Orangebeard, what should I do right now? And Orangebeard would reply with a set of changes, a subset or tests, a subset of tests that is prioritized in the right way. Then we can start the test run and maybe in parallel start a run for all the other test cases, but not on the critical path. Then we have real-time results being returned from the pipeline into Orangebeard. And those real-time results we can use to make decisions at runtime. Is this important piece of functionality failing in the beginning of the test set? Then let's just stop the test run or sidetrack it. We're not going to release this software anyway, so why have other people wait for this release? And that would help us to speed up the testing process and get it off the critical path and get it from a snail to a snail on wheels that would truly make a continuous delivery a possibility and continuous deployment. So that concludes my story. If there's any questions, feel free to post them in the chat. And otherwise, contact us if you want to know more.
Questions?